Today we start p-adic matrices. P-adic matrices. Let us start this problem now. Let P be a prime number. P be a prime number. And given a non-zero x belongs to Q. Non-zero x belongs to Q. Then we write x equal to p to the power k m by n, where k, m, n all are integers, and p dividing neither, p does not divide it, p dividing neither m or nor n. Okay. Then we define n phi x equal to k, and this now we define p-adic matrix. Define p-adic matrix dp as follows: dpxy equal to 0 if x equal to y, and p to the power minus vp multiplied by x minus y. No, vp x minus y. Okay, that means x minus y, that means p to the power something of x minus y if x not equal to y. Then we have to show that q and d phi vm matrix space. First we have to show this one. Okay, how we do this? This one a important problem. So how we deal with this? Now dp satisfies the stronger, dp satisfies the stronger form of triangle inequality. Okay, then dphi xz less than equal to maximum of dp xy and dp yz. This one. Okay, now we how we do it? We do it so simply. First we take where is this problem? There is the board. Now start in this way. We take a equal to p to the power k1 m by n, and v equal to p to the power k2 l by p, l by r, and c equal to, we write c equal to p to the power k3 and s by t, where v p a equal to k1, vpb equal to k2, vpc equal to k3. Okay, now a difference b equal to p to the power k1 m by n difference p to the power k2 l by r. Okay, then we come on here p to the power minimum of k1 comma k2 That means any one minimum we common there, and then this one is in bracket. Okay, something is in bracket. Not write that now. So this one is common, that p a minus b greater than equal to minimum of k1 v k1 k2 and k1 k2 equal to minimum of vpa vpb. So easy. Then how we delete this one? Minus vpa minus b equal to minus minimum, oh sorry, greater than equal to, not here minus, then this one is less than equal to, because we multiplied by minus symbol, then this one is less than equal to minimum of vpa vpb. So this one equal to maximum of minus vpa minus vpb. Okay, then we write in this way. P to the power minus bpa minus b less than equal to p to the power maximum of minus vpa minus vpb. Okay, then this one equal to dpav less than equal to maximum of vp in p to the power maximum of p to the power minus vpa p to the power minus vpb. Okay, again we do it. So we erase these things now. What do we obtain? We obtain dpav equal to less than equal to maximum of p to the power minus vpa and p to the power minus vpb. Okay, so how we write now? I write now dpac less than equal to in this way. If we do it in this way, then similarly write here, similarly dpac maximum of p to the power minus vpa p to the power minus vpc. Okay, and dpbc less than equal to maximum of p to the power minus vpb p to the power minus vpc. Then we write it so easily, dpav less than equal to this one, that means write maximum of p to the power minus vpa p to the power minus vpb. Okay, and this one less than equal to maximum of p to the power minus vpa p to the power minus vpb p to the power minus vpc. And this one obviously less than this one, we write it, this one equal to less than equal to d maximum of dpac and dpec. Okay, that means any one maximum is greater than this one. Okay, then we prove the stronger form of triangle inequality. Now we discuss about another that means how this one is matrix dphi dpxy equal to 0, then this one must be x equal to y implies that, and x equal to y implies that dpxy equal to 0, and this one obviously greater than equal to 0, that means p to the power minus vp x minus y, obviously this one is greater than 0, so this one greater equal to 0, dpxy, and another one dpxy equal to dpyx. This one, how this one is formed, this one too easy. dpxy equal to, if x not equal to y, then p to the power minus vp x minus y, then this one, and dpyx equal to how much, p to the power minus vpy minus x. That means if x minus y contain p to the power l, then y minus x obviously contain p to the power l highest factor, then vp x minus y obviously l, and here obviously vpy minus x also l, so these two are same, then dpxy equal to dpyx. Understand? Not a problem at all. Then we prove that dp be a metric and qdp be a metric space. Okay, next we discuss about some example here given. What does it mean? That means here given p to the power n also converges in qdp but not in qd. How this one happen? Then here given p to the power n converge in qdp but not in qd. Okay, how this one is happen? This one happened so simply because p to the power n converging to 0. Why? Because dp xy equal to p to the power minus vp x minus y. Okay, if x not equal to y, that means here p to the power n, that means dp p to the power n 0. Okay, then this one equal to some, here some p to the power vp p to the power n minus 0, that means this one is n, that means p to the power minus n. Oh no, here not, this one is converge. Okay, that means p to the power n and p to the power minus, if we write here p to the power minus n, p to the power n, not here we write p to the power n, dp to the power n something 0, then this one is give a value 1 p to the power minus n, and this if we take epsilon, then for n tending to infinity this one p to the power minus n tends to 0. Okay, if p obviously greater than 0, be a prime, then dp p to the power n 0 obviously tends to 0 as n tends to infinity. Okay, not a problem at all. So p to the power n converges to 0 in qdp. Not a problem, but not in qd. Why? Because if d of p to the power n and something has 0, then p to the power n minus 0, this one is p to the power n, does not convert, that means does not less than epsilon or does not tends to 0 as, but this one tends to infinity as n tends to infinity. Okay, or give certain value. So p to the power n is does not converge in qd but converge in qdp. This one is an important problem. Now discuss next things. Where is this portion? So p-adic metric, one important metric to us, which handles further remarkable properties. Okay, this p to the power n also converges in qdp. Now what does it mean to say that a sequence of integer converges to 0 in q with p-adic metric? Then a sequence of integer converges to 0. That means a sequence of integers converge to 0 in p-adic metric. Okay, this one important question. So easy, you will delete, because p to the power n, we see that p to the power n converges to 0 in dp. Okay, so we say about that any sequence of integer xn converges to 0. Any sequence of integer xn sequence of integer converges to 0. Why? Because given n belongs to natural number, there exists n0 belongs to natural number such that p to the power n divides xn. Okay, p to the power n divides xn for n greater than n0. Understand? That means if p to the power n tends to 0, then this xn tends to 0, because xn equal to k p to the power n. In this format, if p to the power n tends to 0 as n tends to infinity, then this xn tends to 0. Okay, so a sequence of integer converges 0 in p-adic matrix. This one is a familiar properties of p-adic matrix, and one great, that means construction of some mathematicians. Okay, now another example, we see that here the sequence xn where x1 equal to 3, x2 equal to 33, and x3 equal to 333, and so on. Okay, then it converges to -1/3 in qdp. How this one happen? This one happens so simply. We write first x1 equal to 3. then x1 plus 1 by 3 equal to how much? 3 plus 1 by 3 equal to 9 plus 1 by 3 equal to 10 by 3 equal to 2 into 5 by 3. x2 equal to 33. Then x2 plus 1 by 3 equal to 33 plus 1 by 3 equal to 99 plus 1 by 3 equal to 100 by 3 equal to 2 into 5 square by 3. x3 equal to 333. x3 plus 1 by 3 equal to 333 1 by 3 equal to 999 plus 1 by 3 equal to 1000 by 3 equal to 2 into 5 whole cube by 3. Then what we get? We get in this way xn equal to 3 dot 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 n times. Okay. Then xn plus 1 by 3 equal to 3 dot dot 1 by 3 equal to 10 dot dot 0 by 3 equal to 225 whole to the power n by 3. Then what we see that? We see that xn minus minus 1 by 3 tends to 0 in not dp, here d5. Okay, or I did in mistake. This one is in d5. So this one tends to 0 in d5 because this one 5 to the power n. Okay, then we write it so easily. We erase this portion first. We write it in metric form d of xn dp not d5. Okay, d5 xn minus minus 1 by 3 equal to how much? 5 to the power. Here if dp, then 5 to the power n into 2 to the power n by 3. Okay, then this one equal to d5 of this. d5 of this equal to how much? This equal to n. Understand? This equal to n. Okay, so here the sequence d5 means 5 to the power something. Okay, we write it 5 to the power dn xn equal d5 xn equal to 0. This converts to 0, not d5. This one equal to this difference equal to this. d5 means 5 to the power something, 5 to the power minus of this, that means 5 to the power minus n. Okay, not 0, 5 to the power minus n. Then this one equal to 1 by 5 to the power n. Then as n tending to infinity, this one becomes 1 by 5 to the power n tends to 0. So what we obtain? So what we obtain? We obtain d5 xn minus 1 by 3 tends to 0 as n tending to infinity. Then this xn converts to minus 1 by 3. Understand? But this one in d5 metric, in D5 about under D5 matrix, this sequence is converged to -1/3. So today we stop here.